Okay, those two segments are medians and altitudes. Okay, I'm not going to have you construct these two. We're just going to estimate so you can see where it's at. So the median of a triangle is a segment whose endpoints are at the vertex of the triangle and the midpoint of the opposite side. Okay, so a median goes from the vertex, so one of the angles in your triangle, to the midpoint of the opposite side. So in our three triangles, we're going to draw in this median. Okay, so we're going from vertex A. Again, I'm just going to estimate the midpoint of that opposite side. Okay, so my midpoint's right here of that opposite side. Since it's a midpoint, those two segments would be congruent. Now to draw in the median, you'd connect those two dots. Okay, for that second triangle, again from the vertex, we need to find the midpoint of that opposite side. Okay, so again, I'm just going to estimate it's about here. Since that's the midpoint, those two pieces of that segment would be congruent or equal. And then we want to draw in the median, so from your angle to that midpoint. Last one, angle A is right here. We want the midpoint of that opposite side. Okay, since that's the midpoint, those two pieces are equal or congruent. And I can draw in my median from those 2 points. Okay, so it's similar. It's similar to your perpendicular bisector, except it's not perpendicular, and it goes through that opposite angle. We need to be quiet and pay attention. All right, so just like with perpendicular bisectors and angle bisectors, there is a point of concurrency for all three of these that you draw into a triangle. So the point of concurrency of the three medians of a triangle is called the centroid of that triangle. Okay, your point of concurrency for all of your perpendicular bisectors is the circumcenter. Your point of concurrency for your angle bisectors is the incenter. And now with your medians, you have a centroid. Okay, so in number 4, we want to draw in all of these medians. Again, I'm just going to estimate, because I know you guys know how to use the protractor to find that midpoint. Okay, just count and divide by 2. So I'm going to find the midpoint of each side. Okay, so I have a midpoint here. Again, those two segments would be congruent. Finding the midpoint here. Again, those two segments would be congruent. And finding the last midpoint, we'll say it's about here. And these two segments would be congruent. Now, I want to connect each of those midpoints to the opposite angle. All right, so with each of those medians drawn in, they should all intersect at a point. Okay? Okay, that's your point of concurrency. So again, that's considered your centroid. So just like with our angle bisectors and perpendicular bisectors, that point of concurrency has a theorem. So we have the centroid theorem. So the centroid is 2/3 of the distance from each vertex to the midpoint of the opposite side. So what that's saying is from this vertex, I'll call it A. This part gets confusing if you don't pay attention. From this vertex A to your centroid, that distance is 2/3 the entire length of that median. Meaning that other section there would have to be 1/3 of that length. Okay, because if I add those together, you get 3/3, which is a total length of the segment, which is 1. Okay, so if you think about it, I'm going to call this centroid O, point O. From A to O, that's 2/3. Okay, that means I could split this entire segment into 3 congruent pieces, right? So if I had an extra point here, this segment was congruent to this segment is congruent to that segment. So you can think about that segment from A to O as being 2 smaller segments if that's easier for you. All right, so an example of this. I'm going to label my midpoint of that opposite side M. Okay, that means I have this entire median AM. Okay, if I say AM is equal to 33, right? What would the length of OM be?
11.
Yes. Okay, so since OM is 1/3 of the entire segment, you could divide it by 3 to get that one section. Now, what would AO be? 22. Okay, so you could either take that one section OM and multiply it by 2, or you knew that the entire thing was 33 and one section was 11, so you could subtract it from each other to get 22. Okay? Does that make sense? Now again, make sure you know the difference between the 2 segments. This 2/3 is from the angle to the centroid. The 1/3 is from the centroid to the side of your triangle. Okay, don't get those mixed up. So we're going to practice some of these at the bottom here. Okay, so in triangle CDE, so here's our triangle. U is the centroid. Okay, since U is the centroid, that means all 3 of those segments in your triangles have to be medians. Okay? Now we're also given UK is 12. Okay? EM is 21, so that entire segment is 21. And UD is 9. Now before I even start looking at the problems on the left, what I like to do is just fill in my whole triangle right away. So if I know UK is 12, using that centroid theorem, what would CU be? 24. Okay, since that part is our 1/3 piece, this would be our 2/3 piece. Okay, now I also know UD is 9. Okay, if UD is 9, that's your 2/3 piece. How could I find my 1/3 piece, JU?
4.5.
It is 4.5. So you can take that 2/3 piece and divide it by 2 to get your 1/3 piece there. Okay, because again, you could think about this 2/3 piece as two separate segments. Then each of those segments would have to be congruent. Okay, then the last segment I have here is EM, which I was given is 21. Okay, so if that whole thing's 21, then UM is 1/3 of that, which would be 7. And then EU would be 14. Okay, now that I filled in my whole triangle, it'll be way easier to answer each of those questions. So number 6, I need to find the length of CU. That's 24. 7, I need to find MU. That's 7. CK, I need to add both of those together to get 36. 9 is JU, 4.5. EU is 14. And J to D, again, I need to add both of those together. That's 13.5. Okay, see how much easier that made it when I just filled in the whole thing right away?
And then we confuse it and add another one.
This one's not bad. Okay, so any questions on medians? All right. On the back, we have altitudes. Okay? The altitude of a triangle is the perpendicular. I'm going to use the symbol for perpendicular. If you don't know what that means, write out perpendicular. Okay? Perpendicular segment from a vertex to the opposite side, or the line that contains the opposite side. Okay, so again, I want to draw in some altitudes. So I know I have to go from the vertex or an angle in your triangle, and we want to draw in a perpendicular line from that angle to its opposite side. Okay, so we want that angle there to be 90 degrees. Now again, this doesn't have to hit at a midpoint. Okay, that would be considered a median then. This one just goes from your angle to a 90 degree on the opposite side. For this second triangle, yep, since this is already a right triangle, your altitude would lie along that line there. Okay, now I don't have this triangle pictured, but I'm going to draw it in. So I want you to draw an obtuse triangle to the best of your ability. Now if I label this angle as A, right, I can't make an altitude go from this angle to that side where it'd be 90 degrees, right? So what this does is extend your bottom line. Okay, and I can draw in an altitude on the outside of my triangle. And that would be your altitude there. Okay, so with an obtuse triangle, to draw in an altitude, you'd have to extend that opposite side to draw it in. Okay, so that's the only one that you have to extend sides for. My picture looks pretty bad, it's fine. Alright, so just like with all of the other segments we talked about, altitudes also have a point of concurrency. Okay, that point of concurrency is the orthocenter. Okay, so we have a circumcenter, an incenter, a centroid, and an orthocenter. So in 15, I want to name the point of concurrency for each segment. So altitudes, we just learned, is the orthocenter. Medians was on the front. That's the centroid. Perpendicular bisectors was what we did last week. That's the circumcenter. And then angle bisectors, again, that's what we did last week. That is the in-center. Okay, so you do need to remember what these are. So if you need to on this note sheet, circle that whole entire thing there. So you can refer back to it and say, okay, 3 altitudes meet at the orthocenter. 3 medians at the centroid. Okay, highlight it, do some things, box it, so that you know where that is on your note sheet. All right, next one. Okay, next one, I'm going to draw in the segments for each of these triangles, and I want you to label what type of segment it is in that triangle. Okay? Okay, so write the name of that segment drawn in for each of those pictures. Okay, is it a perpendicular bisector? Is it an altitude? Is it a median or an angle bisector? All right, this first one here, it's at a midpoint and goes to the opposite vertex. That's a median. Okay, if it hits the midpoint and goes to that opposite vertex, it's a median. Letter B, I have a ray bisecting that angle into 2 congruent pieces. That's an angle bisector. See, I go from a vertex to the opposite side, making a perpendicular. That's an altitude. For which one? The last one, yes. The last one is a perpendicular bisector. Since it hits that side at the midpoint, and then there's a segment drawn in perpendicular to the other segment. All right, last question on here. Okay, we want to compare perpendicular bisectors, medians, and altitudes. Okay, so perpendicular bisectors and medians, what do they have in common? Perpendicular bisector and a median. What do they have in common? They have a midpoint. So both of them pass through the midpoint. Now, with a perpendicular bisector, it doesn't always have to pass through that opposite angle, though. Okay, that's where they differ. So, to write this out, the perpendicular bisector and median both pass through a midpoint. Okay? But only the median must pass through the opposite angle. Okay, so that was perpendicular bisector and median, right? What about perpendicular bisector and altitudes? What do they share in common? Right angle. Okay, perpendicular bisectors and altitudes all hit your side at a 90-degree angle. Okay? So the perpendicular bisector and altitude are both perpendicular to a side. Okay? Now how are they different? What's different between that perpendicular bisector and the altitude? Yep. So the perpendicular bisector would have congruent points, right? The altitude doesn't need to. Okay? So with your altitude, that has to go from your vertex to the opposite side. Okay? Okay? But only the altitude must pass through the opposite angle. Okay, last ones I have to compare is the median and the altitude. Okay, median. Shh, quiet. The median and the altitude. If I look at my pictures, altitude, median, what do they share in common? How are they the same? Not the triangle, the segment. How are those segments the same? What do they have to pass through? The vertex. Okay? Both of those segments have to pass through the vertex of your triangle. Okay? So, the median and the altitude must pass through a vertex. Okay? Now, how are they different, medians and altitudes? Not a lot. We're almost done. I only wrote 3 sentences. Yep. Okay, the altitude has to intersect at a perpendicular. The median has to intersect at a midpoint. Okay, that's how they differ. So, but the altitude must intersect the opposite side at a perpendicular. And that should be fine. Okay, so I compared each and every one of those to each other. Okay? Because you had to compare and contrast all three of them. So you have to do it with perpendicular bisector and a median. Median and an altitude, and a perpendicular bisector and an altitude. So all of those you have to compare. It's not long. It's literally only front sided. No, there's no side to this. Okay, only front sided. The top 6 are like the ones from the front we did with the median. Make sure you read those directions, please. Please get started on this assignment. Those top 6 problems don't take very long. Just like the So this one was 21. How did we get 7? Okay, so 6. Okay, so this one's 6. And what's I knew you were going to say that. How do I get to 18? If this one's 6,
Well, I don't know what. I don't know what you want to do.
12, yes. So that would be 12.
But I don't really want to do
Okay, now that's small second. This is the third. Okay, so YJ is 4.5. YU is 3. JT is 6.
I saw Alex when you comment on your spam post. Yeah. Okay, yeah. I'll give you some more people. And then next one. I'm at 16.